Now let's look at a right triangle. This is a right triangle, and this is the right angle. That means it's 90 degree or pi over 2, and this is the theta, our angle theta. If this side is denoted by A, and this side is denoted by B, okay. So let's extend one more, and let's extend the side to get another triangle, right triangle. Okay, so this is the right triangle, right? This is the right triangle. If this side is B prime, and this side is A prime, okay, so this is A, and this is B. And we know these two triangles, right triangles, are similar triangles because they share the same angle theta. And we also notice that if we take the ratio, A over B should be equal to A prime over B prime, although one right triangle is bigger than the other one. However, the ratio is the same. So the reason is they have this this angle. They have the same angle for these two triangles, right triangles. So it's reasonable to use a ratio to define some functions of this theta, this angle, which is called the trigonometry function. Okay, so now let's look at this. We use a right triangle to define the trigonometric function, trig functions. Okay, this is the trig functions. So let's use a right triangle. So this is right angle, and this is theta. And this side is called adjacent. Adjacent side. This is called adjacent side of the theta. This side is called the opposite side of the theta. This is the opposite side. And this is the longest side of this right triangle, which is called hypotenuse. Okay, and so we use ADJ to denote adjacent. We use OPP to denote opposite, and we use HYP to denote hypotenuse. So now let's define some functions. The first function is called the sine function. Sine function. So we use this one. This is sine function. Sine function can be written as this sine of theta. Okay, so this is the sine function. Sin is the name of this function, like f of theta. F, right? F is the name. So sin is also the name of the function. Okay, so the variable is theta. How to define this one? We use the opposite side over hypotenuse. Okay, the opposite over hypotenuse. If here is, we opposite over hypotenuse. This is called sine function. Let's look at cosine function. Which is denoted by cosine theta. So cosine theta is defined by adjacent over hypotenuse. Then let's look at the tangent function. So this function written as the abbreviation for this function is tan. This is the name of the function. The variable is theta, which is opposite over adjacent. Okay, over adjacent. So these are the three main trig functions. Let's look at another three. This is called a cosecant function. Cosecant function is denoted by SCS, cosecant theta, which is the reciprocal of sine, so it's actually hypotenuse over opposite. Let's look at this is the secant function. Secant function is denoted by SEC, secant function, secant of theta, which is hypotenuse over adjacent, which is also the reciprocal of cosine. Then we have the cotangent function. Cotangent function is denoted by COT of theta, which is adjacent over opposite. So this is the cotangent is the reciprocal of tangent. Okay. So now we want to look at example to calculate these trig functions for a given triangle, right triangle. Okay, if our right triangle is given by this is A, this side, this is theta, A equals 5, B equals 2, and this side is C. This is the right angle. We want to calculate these 6 trig functions. Okay, these 6 trig functions. So the first thing is we need to calculate the hypotenuse, right? So the idea is we use the Pythagorean theorem, right? Pythagorean theorem says, okay, c squared should be equal to a squared plus b squared, right? So c squared is equal to, this is 25 plus 4. So c squared, c is equal to plus or minus square root 29, but our c is the length for the hypotenuse. It must be positive. So c is equal to the square root 29. Okay, so you should practice this mentally again. At last, you need to calculate this c mentally. Okay, very quick. Otherwise, it will cost you time. So we will use this Pythagorean theorem again and again. Okay, so we have everything. Then our sine theta is what? Is the opposite. Opposite is 2 over hypotenuse over square root 29. If you want to simplify it, that's okay. But if you want to simplify, it would be 2 times square root 29 over 29, right? But that's okay. Right, so I use the parentheses. Cosine theta is adjacent, which is 5 over hypotenuse. Tangent theta, which is opposite over adjacent. Cosecant theta, we know it's 1 over sine, right? Or you can just use the definition, which is hypotenuse over opposite. secant theta, which is the hypotenuse over adjacent. Or you can use the 1 over cosine, the reciprocal of cosine. And the cotangent theta, which is 5 over 2, adjacent over opposite, or the reciprocal of tangent. So now we can use from these definitions, from these definitions of the trig functions, we can find some relations between the trig functions. Relation between trig functions. One is if you take sine divided by cosine, sine theta over cosine theta. So sine over cosine. So sine divided by cosine. So you can see hypotenuse will cancel out. So it would be opposite over adjacent. Opposite over adjacent is just tangent theta. So sine over cosine is equal to tangent theta. Cosine over sine, so which is the reciprocal, so which is cotangent theta, right? So this is called the quotient identity. And we also know that there is some relation between sine and cosecant, right? Which is the reciprocal of sine. So cosecant theta is the reciprocal of sine. Or you can just write as sine is the reciprocal of cosecant. Secant theta is the reciprocal of cosine, or cosine is the reciprocal of secant. Cotangent is the reciprocal of tangent, or tangent is the reciprocal of cotangent. So you will see later in the trigonometry part, we have a lot of identities you should memorize. So these are called the reciprocal identities. So all these, and we also have sine square plus cosine square. This is a very famous identity. Sine square plus cosine square. So here is this square plus this square. So if you add up, then you will see that the denominator is the hypotenuse square, right? But numerator is the opposite square plus adjacent square. Opposite square plus adjacent square, you can use the Pythagorean theorem. It says it's equal to the hypotenuse square. So the denominator is also hypotenuse square. So cancel out. You will have sine over cosine is sine square plus cosine square is equal to 1. Similar, you can use tangent square plus 1 equals secant square. This is also from the Pythagorean theorem. You can plug in this. You can plug in the definition to see what happens. Simplify to see what happens. And cotangent square plus 1 equals cosecant square. So all these three identities are called Pythagorean identities. Pythagorean identities. Okay. So here is one convention. We always like to put the function square for the trig functions in the middle. Okay, like this one. This is the powers. This is the powers. Okay, so these are the powers. These are the powers. So here is some convention I want to mention. This is sine square theta. It means sine theta, then the whole thing square. Okay? If you have no parentheses, sine theta square, what does this mean? This means the input is square, theta square. So these two are not the same thing, okay? Especially this part and this part, these are different, okay? Or these three are different. Yeah, the top two is different from this part, right? So you should be careful. So all these identities are called fundamental identities. Fundamental trigonometry, not just trig identities. So now let's look at some examples to help you to be familiar with these identities. So we want to show that proof that the sine theta times cosecant theta is equal to 1. Okay, so how to prove it? We always transform the left side. For this example, we need to always transform the complicated side to the simple side. So here, in this problem, the complicated side is the left side. So we transform the left side into the right side, okay? We start from the left side, so we write proof. So sine theta times cosecant theta, Cosecant theta is equal to what? Equal to sine theta times cosecant is 1 over sine, right? So this is equal to 1. Then we finish the proof. Or you can just show that. Another example is we want to show that the cosecant theta plus cotangent theta times cosecant theta minus cotangent theta equals 1. Okay, so now let's look at, let's prove it from the complicated side. Cosecant theta plus cotangent theta times cosecant theta minus cotangent theta. So which is actually a plus b times a minus b, so it's equal to a squared minus b squared. So this is the cosecant square minus cotangent square. So you see I put a square in the middle, right? Okay, and we know that cosecant minus square minus cotangent square from this identity, right? It's equal to 1, so we just write down cosecant square equals cotangent square plus 1. So it's minus cotangent square. So it's equal to 1. Then we finish the proof. Okay. So now let's look at another example. So in this example, one trig function will be given. For example, we assume sine theta equals 1 over 4, where theta is an acute angle. We want to find the other 5 trig functions, right? So here, this is, of course, you can use the identities, right? Method 1. We can use identities. To find the other 5. Or we can use method 2 is the one way I want to state here. Because here, if you use the identities, the one problem is, if you want to calculate the cosine, you can use the cosine square plus cosine square equals 1. Then you need to take the square, but the problem is we should take the positive square, a positive square root, or the negative square root. Okay, but we didn't have this knowledge yet, but actually it should be a positive square root. The reason is it's an acute angle, so everything is positive. Okay, so the method 2 here, I want to use, since we know the sine is the opposite over the hypotenuse, so it's a ratio, right? It's a ratio. So we can draw a right triangle. Let's draw a right triangle to make the opposite over hypotenuse is 1 over 4. This is theta, this is right angle. So we set this opposite is 1 unit and the hypotenuse is 4 units. Okay, has 4 units. So the ratio, the sine theta is 1 over 4, so it satisfies the conditions. Okay, we can do that because the sine theta is just the ratio, right? Of course, you can set the opposite to be 2, then the hypotenuse should be 8, right? You should keep the ratio to be 1/4. But for our convenience, we just set 1 for the opposite, the hypotenuse to be 4. Then we can use the Pythagorean theorem, okay, for this side. This side is 4 square minus 1 square, take the square root. So which is square root of 15, right? So you should be able to calculate the side if you are given 2 sides in a right triangle using the Pythagorean theorem. Okay, so now we have 3 sides and we can calculate the sine theta. Sine theta is 1 over 4, we know. So cosecant theta, which is 1 over sine, right? So it's 4. And the cosine theta adjacent, square root of 5 over 4. And the secant theta is just 1 over cosine, so it's 4 over square root of 15. And the tangent theta is 1 over square root of 15, right? So the cotangent theta is square root of 15.